Hello everyone, welcome back to another STEM Helps video. Today we continue on our discussion with the relationship with position, velocity, and acceleration. So I'll continue on my graph. X with respect to time. That's a bit too small. Velocity with respect to time. And let's put acceleration with respect to time here. Acceleration with respect to time. And we had an example previously, which was a bit less intuitive than usual, but hopefully you managed to understand. So let's say that I'm correct on all this, right? Maybe I'm just making up some mumbo jumbo, but let's see how this applies and why we're taking the slope at a certain point. Why does this make sense with respect to the units? So what is position? So position, let's say we have it in meters. In meters, right? What is velocity? Velocity is meters per second. So how do we get from meters, and we're supposed to multiply by some number to get to meters per second? Well, we have to divide. We can say divide by seconds, right? This is the exact same thing. Or what I'm looking for is we multiply by 1 over seconds, right? It's the exact same thing. You assume that this is over 1 and then you multiply out and it's the same thing. So how do we get to this process? Well, if we have meters, let's say if we have at time t equals 0, we have the position is going to be 7 meters. At time equals 5, we have this as going to be, let's pick a random number, 37 meters. So we talked about the velocity as x2 minus x1 over y2 minus y1 for x2 minus x1, right? Because t's are our x value here. If you know the slope formula, that is exactly where everything comes from. But let's talk about how we get from that in units, and I'll be focusing more about these units now. So x final is 37 meters minus 7 meters, and divide that by 5 minus 0 is just 5 seconds, and that gives us 37 minus 7 is 30 meters per every second, 5 seconds, which is equal to 6 meters per second. And so you can see that by taking the slope, we finally get to this conversion that we've made right here. And same with acceleration. Let me just bring this down. If we have a velocity of 7 meters per second at t equals 4, and final velocity is 14 meters per second at t equals 5 seconds. Well, you can see this in your car. If you're going from 7 miles to 14 miles per hour in from 4 to 5 seconds, or 7 to 14 miles per hour in 1 second, you know that you have accelerated 7 meters per second squared. And let's write that out. Oops. And this is not supposed to be initial. This is supposed to be final. And let's write that out in just to have familiarity, because it's much easier to see. So v final minus v initial, so 14 meters per second minus 7 meters per second, all divided by, well, final minus initial time, which is 1 second. And that's very important, and we can use the property when you divide fractions. Let's say if we have a little side note here. Let's say if we have note, if you have a divided by b, this is equal to a times the reciprocal of b, 1 over b. And that is our note. So if we go over here, we can say 14 minus 7 is obviously 7 meters per every second. And we can use this formula, and you multiply by the reciprocal. You multiply by 1 over seconds, or 1 times 1 over seconds. It's the same thing. And right now, we can make this as 1. 7 meters over 1 second times 1 second, which is 7 meters per second times second, which is second squared. And so that is how we get this formula, and it seems more intuitive. And if you go to our equations on projectile motion, and I'll just write a couple of them for you. So position is equal to VOT plus 1/2 AT squared. That is one equation, and if you ever have the chance to take calculus, this will make complete sense to you. And when you talk about area under the curve. But the most important one I want to talk about is V final minus equals V initial, or usually people say VO, I say VI, but usually your teacher will say VO, plus AT. Now let's rewrite this, right, to just make this more simplified. Let's solve for A. So A, here, let me write this in a different color, just makes it more sense. Here, let's have a very feminine color. A is equal to, I skipped a step. So if we subtract VO from both sides, VF minus VO equals AT. And since they're bound by multiplication, you divide both sides by T. So A equals VF minus VO over T. So this equation is of the long list of equations. This is one of them, which is pretty straightforward. It's the definition of the acceleration. So we can see that we could just use our logic into finding a very fundamental rule of physics. Now let's go back to our graphs here. And you can see that when you have a point and another point, and when you graph this, this is negative, by the way. Let's say this is negative. This is round over here. You can see that they more or less correlate with where it is in the graph. And of course, I had rough sketches, but you can see that they correlate with where they are in the graph, and I hope that's helpful.